Good evening, Abhilash sir. Let me know if you can hear me loud and clear.
Yes, very good evening. You're loud and clear, Sanya.
Thank you, sir, for your response. Now I'll make you the presenter so you can get started with the session.
Perfect, thanks.
Happy learning, everyone. Thank you all.
Hey everyone, good evening. Good evening, guys. Perfect. Let me quickly share my screen and we can get started. Okay, yes. So the screen is visible, everyone. Perfect. What we did yesterday, guys? What was okay? We did recommendation engines, right? We completed the recommendation engines. And today we will be starting the natural language processing. Day 14. Okay, so I am uploading all the reference codes and files, data files in NLP folder day 10. Okay? Yes, yes. Please download the resources and let's get started with the NLP. In recommendation engine, we have few more cells which are hidden. Is that unimportant? Okay, right below. Those were the cells. Those were the cells to implement that a priori and everything from scratch without using the algorithm. Those were the cells. If the file is still open, I can just show you. I think no. Recommendation engine, I have closed that file. Those, yeah, here it is. No, it's there. So if I scroll down, these are the cells to implement that logic of permutation and combinations and creating rules from scratch without using that library. So if anyone is interested to see how to build every code from the very scratch without using the library, so you can explore these codes. Okay. Sorry. It will take, there is a huge amount of data there. There is huge amount of data there. Dogs fighting. I don't know why. What happened? What's wrong? Oops, who is this? Excuse me, guys. Let it be. No, I don't have dogs. My mom says we are glad to have only one. So she don't allow any other dog. Okay. So we need to start with this NLTK. Does MacBook perform better with respect to Python and are working? It will perform brilliant. If you treat it well, it will perform brilliant if you treat it well. If it is core Python and programming stuff, it's brilliant. Honestly, it's brilliant. But when it comes to the video editing and graphic kind of stuff, then it is not that good. Then I would say go for the Pro, MacBook Pro. M1 Mini, I'm not sure about the Mini, but M1 is good. MacBook M1 and M1 Pro is also good. No, we haven't started anything yet. 8 core CPU, 8 core GPU, 8K editing can be done. Yes. Is that M1 Mini? Okay, nice. Ah, got it. Mini Mac. So after buying a mini Mac, you need a desktop. You need all other devices also. Yeah, monitor, keyboard, and everything. Okay, let's come to the topic, guys. Let's come to the topic. Now, we are going to start the natural language processing, NLP, natural language processing. Now, the definition and everything has lot more, lot more language written. But long story short, again, NLP is all about when we work with the text data, documents, reviews, right? Or how search engine works, how sentiment analysis works. Basically, whenever we have the text data, we want to work on any kind of approach, any kind of project, any kind of model we want to build on the text data. It's a natural language processing. How to treat, how to clean, how to process, how to manage the document, the huge text data comes under the natural language processing. Easy? Easy? Perfect. So first of all, in order to, in order to implement the natural language processing stuff, we need a library that is NLTK. NLTK stands for Natural Language Toolkit. NLTK stands for Natural Language Toolkit. So first, let's import the NLTK. Just execute this import NLTK code. Let me know if anyone is getting module not found error. Just execute import NLTK, and in case anyone is getting module not found error, please let me know. Done, everyone? Yes, guys, is it done, everyone? Perfect. Perfect. Now, second step after importing the NLTK library, if we are using this library for the very first time, we need to download some supporting files, some supporting data for NLTK library, right? Now, what kind of data it will require? Some dictionaries, some vocabularies, those sort of things that NLTK refers while working on the new data sets, right? So NLTK, we can consider it's already a trained library, a pre-trained model. NLTK has a lot of pre-trained models, pre-trained machine learning models. That gives a lot of easy stuff. That gives a lot of functions to process and to manage the text data. So in order to utilize those pre-trained models and pre-trained functions, we need to download the respected data. Make sense? Yes? It has a lot of pre-trained models. It has a lot of pre-trained objects that can help us in number of pre-processing things when it comes to the text data. So in order to utilize those pre-trained models or pre-trained objects, we need to download the respected data, right? And how do we download that data? We just need to execute nltk.download function. Okay. So once I'll execute nltk.download, it will simply pop up with a new window like this. Right? This NLTK downloader window will come up. Yeah, please execute this and let me know if this kind of window came up. Perfect. Now we just need to click on download. So all okay, there could be some updates. So this is saying partial downloads for NLTK and all Corpora. So I'll click on download. It could take some time, guys. This is a huge. It could take some time. So just click on download and leave it until this will get finished. Exactly. We need to download all of them. We need to download all of them. Status is out of date for your current versions. When you will install, it will say updated. Status, if it is out of date, that is telling the current status. Okay? If it is saying out of date, means that's the current status. Currently, it is out of date. Right? Correct? Yes, guys? The code is simple nltk.download function. It's simple nltk.download. Okay? Yeah, do it, guys. Please, click on download, everyone. There will not be any window to select or something. You just need to click on download. It will download everything. Is there anything to select or something? Yeah, just click on download. Any pop-up, you just need to check here this taskbar. Just check your taskbar if there is any new Python window. Is there is it there any new Python window? Correct? Yes, that is okay. Default location. Perfect. So Yes, that will not be a big deal. It will be able to download. So I just closed and this will simply return me the true. Now, if it's downloading, let it download, guys. It's gonna take more time. So let it download. We can proceed with the things. Status is showing as partial means that's your current status. It's partially downloaded right now. When you will click on download, it will download it completely. So if it is saying partial, it means it is telling the current status. Yeah, if it's saying downloaded, you can simply close it. Yes. Awesome. So let's create some random, not random, like I'm just taking a data, text data. So this is how the data looks like. We just have a text document, a text paragraph. Okay, good, perfect. So we simply created a string variable that has a huge amount of text, means not very huge, but it has a small document, right? Okay. So the next step is when we do the analysis, we try to split the data with respect to either words or with the sentences. And that thing in NLP is called tokenization, right? The very first thing we try to do is we try to split the document with respect to text or with respect to the word or with respect to the sentences, right? No, not with the letters, because splitting on letters is we will be only getting the letters, so that is not something very helpful. So we only do it by words or by the sentences, and this method is called tokenization, right? This method is called tokenization. Clear? Sure, sure. Basically, whenever we have a text document, a paragraph like this, we try to split it, right? We try to split it into different sentences or in different words, right? We split it into different sentences or in different words. Clear? Is it clear, everyone? Awesome. And this thing is called the tokenization itself. So first of all, from NLTK we are importing sentence tokenize and word tokenize. So when we give sentence tokenized data, it will give the sentence, and when we do word tokenized data, it will give the words. Okay. This download pop-up need to close. Yeah, you need to close it before we execute anything else. The download pop-up needs to be closed before we execute anything else, guys. Make sure we close the download pop-up. Clear, guys? Okay, so this tokenization makes sense? Yeah, what is the error? Please tell me the error. Oh, okay. It's searching in the default location how to set my downloaded location. I think we need to change it in NLTK configuration file. We need to change it in NLTK configuration file. And that is .py nltk.py. You need to go to the nltk.py init.py. We have installed the nltk library, right? So inside Python folder, inside Anaconda folder, there'll be a folder named site packages. The folder to set location by word location. See, let me tell you how exactly we can do this. Inside Anaconda, there'll be a folder site packages. Okay, there'll be a folder site packages. Inside the site packages, we need to search for NLTK, and inside NLTK there will be init.py file. Inside init.py file, we need to search for the line where the directory is mentioned, the directory is specified to look for the corpus data. That's how we can change it. Can I copy the folder to? Yeah, that is also a possible solution. You can simply copy the folder, or you can delete it, download it again. Anything. You can just copy it and copy and paste it on the specific directory, or you can delete it from there and download it again. Anything would work. Anything. Now, Anaconda will be there if, like, you have installed Anaconda, right? Anaconda or Anaconda 3. So, Anaconda 3 folder must be there. Yes, inside C users, your current user, there will be an Anaconda. The download could take time. You can just leave it until this finishes. Okay, perfect. So let's come. The bar shows around 30%. Okay, leave it. It will take time to finish. So we need to wait. You just need to wait until that finishes. Okay, the sentence tokenize and word tokenize. Is it clear, everyone? Sentence tokenize and word tokenize. Is it clear, everyone? Yeah, it says all green. You can close now. Great. So now this is the sentence tokenized, this is the word tokenized. But now again there is a caps or something, so let's make it everything lower. So in order to make everything in a lower case, we can simply do this. I dot lower for I in word tokenized data. Right? I dot lower for I in word tokenized data. So it will simply iterate all the words and make it in a lowercase. This list only has the words that are in lowercase. Okay. Which thing? What takes time to execute? It takes time to execute data. The download or something? Print data. No, it should not take time to display the data. No way. It should not take any time to display the data. Yeah, it should not take any time. If it's taking, make sure you close the window. Make sure you close the download window before you execute anything. Yes, NLTK data is heavy. The data is heavy, guys. Yes, the data is heavy. Okay. So are we good with this I dot lower, making everything in lowercase? Perfect. Now after this, what we usually do, we remove those words that are not very helpful. We simply remove the words that are not very helpful. Please show the data code. Have you downloaded this file? Have you downloaded this file? Please download and use the file from here itself. Please download the file from day 14 and you have all the codes. Okay, so now what we do next is we try to remove the words that are not helpful in order to capture the context, right? We simply need to remove the words that are not helpful for the context. Possible? No, there are certain libraries, there are certain functions through which we can simply remove the one that are not helpful. Now, first of all, let's see what exactly are the words that are not helpful, like is, the, of, it is, as, a, of, these words, right? A, these words are not helpful. They are not going to tell us anything about the context, right? Right? They're not going to tell us anything about the context. These are basically used to form a sentence. In NLTK, these are called stop words. In NLTK, these are called stop words. So we simply remove these stop words. We simply remove these stop words by nltk.corpus data. So first of all, nltk.corpus import stop words, extracted stop words for English. So these are the words that are not helpful for detecting the context of a document, means what exactly is the subject, what exactly is the topic in this document. So that is something we can simply extract by using the stop words. And now we can remove those stop words from our data. We can remove the stop words from our data, right? Right? Okay, now we simply imported the stop words. Now the next step is Okay, apart from the stop words, we also need to remove the punctuation symbols, right? So punctuation symbols are also something we don't want. Okay, what was this? Let me just remove everything and let me just show you what is the punctuation. Okay, so these are the punctuation symbols, right? These are the punctuation symbols that also needs to be dropped. Clear? Now what we are doing, we are simply iterating I for I in word tokenized data if I dot lower not in stop words and I dot lower not in punctuations. So this list comprehension can only store those words that are important to us, right? This list comprehension will only store those words that are important to us. Means it will remove the punctuation symbols and also it will remove the stop words. So right now we only have the words that can tell us about the document. Now see machine learning, ML study, computer algorithms, improve automatically, experience part, artificial intelligence. So these words will give us the most accurate information about the document, right? Right? Make sense? So this is one possible type of pre-processing. This is one possible type of pre-processing. Okay? Clear? Cell number 15. Okay, so this is list comprehension. Do we know list comprehension? Yes, do we know list comprehension? Yes, we don't want the punctuations, we don't want the stop words. So we simply wrote a list comprehension to remove the stop words and the punctuations from a given document. Okay, so at the end, the variable rem stop words is only having those words that are important for us. Okay, perfect. Now, after this is one possible way of pre-processing where we simply did the tokenization and we removed the stop words. Second thing, next way is the stemming and lemmatization, right? Now, stemming and lemmatization is what? Identifying the similar terms, right? Identifying the similar terms. So, for example, programming, programmer, programs, all these 4 or 5 different words are having a similar context, right? Yes, yes, they all are having a similar context. So, in order to identify all of them as a same entity, as a same feature, we use either stemming or lemmatization. What is regex? We haven't used. Okay, I'll tell about the regex. We haven't discussed the regex yet. End of file while parsing for line 15. So make sure the closing brackets and these parentheses, everything is in place. Make sure everything is in place. Great. Now, when we do stemming will simply extract the common term out of similar words, right? A common term based on the pattern from a similar words. In case of stemming, not necessarily it needs to have some certain meaning, some sensible meaning. So if I execute the portal stemmer, a possible type of stemming, so we see machine, it's MACHIN. So in the corpus data of NLTK, there must be some pre-trained object that can stem the similar words, and there will be a lot of words related to this common keyword, right? Machinery, machining, there could be a lot of possible such words, lots of possible words should be there, and that have the same root term, that is this, right? Also this, but see, these root terms, these common terms are not carrying any significant meaning, right? They are just a common term, they are just some common pattern from a similar looking words, right? They are not actually carrying some significant meaning. Make sense? Make sense? Great. On the other hand, if we do word lematizer, yeah, so it's gonna get some meaningful common entities, right? Whenever we do the wordnet is a type of dictionary available in NLTK. So whenever we do lematizer, we will get something meaningful. It will only return, like it will do the same thing. It will extract, it will try to, put the words with exactly same context as a common word, but that common word what we will be getting in case of lematizer is going to have some significant meaning, unlike stemmer will simply extract the common term, right? Clear eyes? We are not stemming and then lematizing. We can directly lematize. What we are giving is simply the word in a like that specific list what we have created. So we can directly do the lematization. It's not like we need to do the stemming and then lematization. These are two methods. We can either go with the stemming, we can either go with the lematization. Completely depends. Clear? Yes, guys. Clear, everyone? Yes, good question. When we should use stemming, when we should use lematizer. Whenever the word their meaning is necessary, then in that case we need to use lematizer. But if the meaning is not important, that word is going to behave as a feature, right? Then we can use the stemmer. For example, in case of classification. For example, in case of classification, we want to classify the texts, right? Let's take an example where we want to classify a text as a positive text or a negative text or any possible classification, right? We just need to classify the text. Now, now, how the classification algorithm are going to behave? We have the words, right? we have the words, and it will simply check if this word XYZ from the training data, how many XYZs are present in positives, how many times it is present in negatives, right? Right? And if this thing is present in some new content, in some new text, it will just observe this positive ratio and negative ratio, and how many times this word was there in positive comments, how many times this word was there in negative comments. Based on this, the new comment will be given the weight, whether it's a positive or negative. Make sense? Make sense? Right? Right? Now, in this case, the XYZ needs, like, we don't actually require the meaning of XYZ. If this is not a meaningful term, it's only going to be used as a feature, right? It's going to be a feature only. It's not going to be a meaningful word. It's not necessary to have a meaningful word here, right? Make sense? When we should use lem normalize, and basically when basically we use lemitizer, or when we basically use the stemmer. Does this make sense, everyone? Perfect. So in case there is a approach, there is a requirement where we need to use exact meaning of a given word. For example, article paraphrasing we are trying to build, or we are trying to create a chatbot where we should return something meaningful, right? Or we are trying to identify the topic. We are doing the topic modeling. So in that case, the word needs to have some significant meaning. Then only it will give some, it will give some important or some meaningful, some useful insight. In that case, we need to use lemitizer. Make sense? When we should use stemmer and when we should use lemitizer? Clear, everyone? If any spelling mistake be there, what we will take? In case of spelling mistake, the limitizer or stemmer, no one will be able to identify the context. So if there is a spelling mistake, then actually, like, limitizer or stemmer will not be able to capture anything in that case. Okay? These methods, these transformation techniques can only work if we have a right data. Yes, limitizer, whenever there is a requirement to get the terms that have some significant meaning, some sensible meaning, then only we will be doing limitizer. If the content or the terms or the words are going to be utilized as a feature only, then we can use stemmer. Make sense? Everyone, make sense? For example, text classification or something. It means lemitizer and stemmer are kind of dictionary libraries. No, actually, they are a kind of text transformation technique where we convert the similar words to a common word. Like program, programmer, programmers, everything will be converted to a common word. That is program or whatever it could be. Clear? Clear? So if we want to simply do the stemmer, if we try to stem the programmer and other things, just a sec. Yes? Exactly. Now, in case of stemmer, it's not very necessary to have, like, to get something meaningful. It could be anything that does not carry any meaning as well. Like you can see here, machine, right? Understood? But in case of lemitizer, it's gonna give something meaningful. It will be giving those words that are carrying some sensible meaning. Understood? That is only when it knows about it, then only it can convert it. So from where does it know which word will be converted to which particular? Remember we did nltk.download. Yes. So everything is here. Everything is here. Okay. Perfect. Now stemming and lemmatization. These two things are clear. Stemming and lemmatization clear, everyone. Awesome. The next thing what we can do with the text data in NLTK is to do the part of speech tagging. So let's have some small sentence and we are simply doing NLTK dot part of speech tagging and we are giving the words. So it is telling what every word belongs to which specific part of speech. So this word belongs to DT. Now what is DT? DT is a determiner. Yeah, DT is a determiner, right? Similarly, little JJ, this is an adjective. If we check what is JJ, it's an adjective, right? Then mouse, NN, stands for noun. So the mouse stands for noun. What is NN? Noun, singular noun, right? Eight is a verb, again determiner, adjective, and a noun, right? So post tag function part of speech tagging will simply return the part of speech for every word. Easy? Yes, guys, easy, everyone? Awesome. Oh, sorry. Regex stands for regular expressions, and regex are basically used in order to extract the patterns. Regex regular expressions are basically a specific library, and that is there in every programming language. It is used to identify, to capture a specific pattern in a given data or in a different types of words, right? Can we use help post tag? Will this give above output? This abbreviations. How does this? How does each and every abbreviation works? No, help doesn't work in Python. There is no help function in Python. I think help is there in R, right? Oh, it's there. I haven't used it so far. Let me check. Post stack. So it gives the docstring about a function, but not the abbreviations. It gives the docstring only, but not the abbreviations. It only returns the docstring for a given function, but it doesn't give the entire abbreviations. Yeah, and like the abbreviations are right here on the cell itself. Great. So are we good with the post stack function, everyone? How they uses NLP, we'll talk about that after we finish this session. Okay, let's finish the basic operations of NLP and everything. Then we will see. Okay, now the next thing, we can actually extract the phrases. We can actually extract the phrases. Now, what do we mean by extracting the phrases? Means just give the pattern of the parts of speech, and let's say, suppose we just let's see this example. I want to extract a noun phrase, like so I'll simply give NP noun phrase, and then I'll give the pattern. If there is any pattern like a determiner, an adjective, and a noun, if there is any pattern like this, extract it as a noun phrase. So I have specified a rule for extracting the noun phrases. Now, noun phrase is not something predefined. It is what we are creating. We are naming a phrase. So we want to extract such phrases where the pattern should be an adjective, the determiner, adjective, and a noun. Right? If there is any such pattern, extract it as a noun phrase. Right? And NP something again we are deciding. Name it as a noun phrase and extract it as a noun phrase. Now chunk parser is equals to nltk.regex parser give the grammar. Specified the grammar, created an parser object. Now we are giving the token to parse it in here. Okay. So if you see the sentence, the little mouse ate the fresh cheese, it extracted the noun phrases, right? It extracted the noun phrases. The little mouse, the fresh cheese, right? And it is only extracting the given pattern. Determiner, objective, noun. Determiner, objective, sorry, determiner, adjective, and noun. Determiner, adjective, noun. Right? Your software specific configuration parameters or set the path environment variable. That error means, okay, are you getting error in cell number 25? So in this case, we need to install a ghost script. We need to install ghost script to display a tree like this. Let me share you the link to install the ghost. Okay, so use this to install the ghost script to resolve the error. Everyone, we actually need to install it. Yeah, so in order to display the result like this, we need to install the ghost script. Yes, I have shared a file. You need to download the ghost script from there. Okay. Yes, guys, clear everyone. We just need to install the Ghost script. And what exactly is happening in this cell is also clear. Cell number 25, what's happening here? Is it also clear? Perfect. We don't need to run any code. We just need to download and install the script. Don't need to run any code or anything. We just need to download and install the script. Sure. So apart from the noun phrase, we can create another rule. It's just about the rule, whatever rule we want to, specify. So preposition, then any types of verb, then any type of, I think, RB, it's adverb or something. Yeah, any type of adverb. So this is another example of a verb phrase where we need to simply we will simply try to extract the preposition, any type of verb, or like there could be anything in between, and extract the adverb. I can remove the star, it will still work. Preposition and okay, my bad. She is working quickly. Okay, anything out of this, and then anything between these. So we specified another rule, that is the verb phrase, where we said if there is any preposition, then any kind of verb, and then any kind of adverb. Extract this pattern as a verb phrase. So she is walking quickly to the mall. She is walking quickly is being extracted as a verb phrase. Right? This is just to extract some more. I'll just again guide you how to install and set up everything. This is to extract the meaningful information from a huge document, right? Sometimes we just need to extract some more important and meaningful phrases, or some possible applications of this is article paraphraser. Paraphraser means if we want to paraphrase something, the context should be exactly same. The way we are writing a sentence should change, right? The context should be exactly same, but the way we write a sentence should be little changed. So in that case, we can simply extract the phrase and rewrite the phrase by some another rule. Yes? Yes? Clear? Clear everyone? what exactly, like, what are the possible applications of this uh, parsing? This is called chunk parsing. Yes, is it clear? Extracting the phrases based on the patterns on parts of speech, and we can, utilize it to paraphrase, or we can use these things as, the features for further analysis and other things. Make sense? Article paraphrasing. Okay. In case of, have you installed the Ghost script? Have you installed the Ghost script? After you installed it, we might need, if the environment variable has been added by default, if the environment variable have been added by default, it's good. Otherwise, it needs to, should I download the 32-bit one? It depends on your system. I can't tell you like what should be, what should you download. It completely depends on your laptop. If it is 32-bit, download it for 32-bit. If it is 64, download for 64, right? It depends on your operator. 64, download 64. For Mac, this is for Windows. For Mac, there is a brew statement, brew install, homebrew install Ghost script. So for Mac, just Google it how to install Ghost script in Mac. There is a homebrew statement. You don't need to download and install it this way. This is only for Windows. Okay, download and install this Ghost script, guys. And once it is installed, add a path environment variable to the executable file of the Ghost script. Right? Just install it. Try to locate with.exe. The executable file of Ghost script is available. Give that path to the, like, copy the path and save it to the environment path variable, and then try to re-execute the code. Okay? Does this make sense, everyone? Yeah, we need to specify the path. We need to specify the path in environment path variables. You just need to go to the control panels and search for the environment path variables, right? Go to the system variables. Wait, let me show you the entire steps that's available. Wait a sec, I'll show you the screenshots. Okay, let me show you the screenshots to everyone. Let me show you the screenshots. Yes. So you need to download it from there. Then copy this path, program files, gs 9.23, and bin. Here we must be having a DLL, dynamic link library, and lib, the library files, and also we have the exes applications. Copy this. After the install, copy this path, guys. Make sure we see these files available in the program files. Copy this path and add it to your environment variable. So how do you get the system properties? Click on settings, not on settings, on environment variables. See, this is the path. Go to the environment variables. Then there is a variable path. You need to add this path inside this path variable. Add new. Clear? Clear? Again, you can check. You need to download. Once the download and install is done, copy this path and add it to the path environment variable. Clear, everyone? No, you just need to add a new. You don't need to change the previous one. You just need to add a new here. There is a button new, right? Do these steps and then try to install it again. Sorry, try to execute the code again. Do these things and try to execute the code again. Perfect. So yeah, we can try this. Now, what exactly was this chunking? Is it clear, everyone? What exactly is we are trying to do extracting the phrases? Is it clear? Extracting the phrases, clear, everyone? Perfect. We can proceed to the next topic. Yes, guys, we can proceed to the next topic. What's lookup error is lookup. If you are getting a lookup error, that means the download statement is not completed. What's about brown corpus? It's actually a type of data. Whenever we do the download, when we do the nltk.download, it downloads some corpus data. So brown corpus is also a specific type of corpus data that is something we download while using the nltk along with this download function. Lookup error is something you will get if the data is not downloaded completely. Clear? Okay, so all these things are clear, everyone. We are good with all these concepts here in this file. So these were the basics. Now we will try to understand some more text transformation techniques. Means how do we convert a huge document into vectors, and how we can actually implement the classification and other kind of things on a text data. Okay, so these are some basic operations, some unit operations, what we can apply on a text data. Next, we will try to discuss how we are going to transform an entire text document or text data into vectors, into numbers, and how again we can create a classifier and other types of models on a text document. Understood till here, everyone? we finished the basic operations. Tokenization, stemming, lemmatization, then part of speech tagging, and then extracting the phrases. That's what we have done. And now we are going to work on the vectorization. Unable to find the GS file, the path and everything is done. Okay, anyone? Yes, guys. What about this? Is that thing sorted? Yes. What about this, guys? Is that thing sorted? Doing. Okay. So have you added it in path variable itself? Have you added it in path environment variable itself? I reinstalled it after specifying the path, then it worked. Awesome. Sure, sure. Let me share you the screenshots. Give me a moment. Or you can use code also. Day 14, day 14, day 14. Here it is. For Mac, you just need to lookup error is because the data is not downloaded. Lookup error is something you will get when the data is not downloaded. NLTK.download is not in place. The screenshots, they got stored in desktop. For Mac, there is a homebrew statement. There is a brew command to install for Macs. So you can simply use that brew install go script. Let me tell you this code for. Let me just share you the command. Yeah. Yeah. Download this. Okay. Perfect. Yes, guys, let me know if anyone is struggling with lookup error or any kind of error in this file, please. Let me know if anyone is struggling in any kind of thing here. Now working? Awesome. Oh, not working. My bad. I thought it's now working. Did everything? It's still not working. Oops. Okay. It will be good if you can share the AnyDesk. If anyone can share me your AnyDesk, I can check, please. Yeah. Please share me the AnyDesk, anyone? Thanks. Okay. So it's working. What's wrong? I think I can see the output on your file. Oh, okay, no problem. Just a sec, guys. Download button. No. Okay. Yes, everyone can see my screen. I'm trying to install the Ghost script here. Program files. Yes. Yes. Okay. First, we need to uninstall. Oh, you already have installed it. Close. Okay. I agree. This is the path. Install. Now you just need to go to the control panel. Need to restart? No, actually don't need to restart. Need to restart the Python itself. Just restart the kernel, it will work. You don't need to restart the entire system. Simply restart the Python, it will work. Or simply restart the kernel. local disk C, program files, GS, go script, 9.5, and then bin. Control C, and here, okay, you said double click on path. Let me check. This already have something. We don't need to change the existing path. We just need to add a new path and save it here. Okay. Okay. Now let's see. Word tokenize is not available. Let me execute all these cells. You have not installed, you have not done the nltk.download. You have not executed the nltk.download. So you are getting this error because nltk.download is not finished. Okay, let's see if this works. You need to download that first, but it is still giving the NLTK error. You might need to was unable to find the GS file software configuration parameters. Okay, let me check the another system. Yes, guys, was it done for anyone? Is it done for anyone? Okay. It's not pasting. Paste. Okay. Can I just see the code? Lookup error. And is the environment path variable download, like you have created an environment path variable? Okay, okay. Added. Oh, it's done. I see, it's done. Can you simply restart the this specific notebook and try to do it? Just restart the kernel. Just restart the kernel. Okay, already done. Still it's not working. Let me check. Okay, let's see what exactly it's telling. Installing DOS, MS Windows. Okay. So one possible cause could be you might need to restart the Jupyter notebook. Try restarting the Jupyter notebook. Yes, try restarting the Jupyter notebook also. Argument 3 must not be 0. Please give me the code. Please give me the code. Okay. And the error, what error you are getting? Value error. Okay, in which line of code it is actually giving this error? In which line of code it is giving it? It should be specifying the line also, because there is no function where we are giving the third argument. Can you please copy the entire error statement? Can you please copy the entire error statement? Return method traceback dot py. Okay. No, this isn't complete. There must be something more on this error statement, because right now and util.py. That's all. Let me check. Let me check. It ran, Praveen. Awesome. So what you did, you restarted or something? Traceback in formatters.py, tree.py, utils.py. So it's giving error only on py files. It's not actually trying to specify where the error is there in the existing code. Restarting worked. Yeah, yeah. That is the only thing. That's the only thing left. Restarting the system. Okay, Walid, can you please quickly share me your AnyDesk? I can check then. Perfect. What error it's showing? Lookup error. You need to install the NLTK corpus data, plus you need to install the Ghost script both. NLTK corpus and Ghost script both you need to install. So install the NLTK corpus, install the Ghost script, and also add an environment path variable. Range 3 must not be 0. Okay, okay. Guys, please do one thing. Please post the screenshots and everything in community, because I see there is something got updated, or there is some other thing, because if the Go script and everything is installed and everything is in place, and still we are getting this new error, please please paste the screenshots and the error on community. We'll try to see later on. Okay. Yes, guys, this might take some time. So please post these errors and everything on community link. Might need some time to debug. Do we have the community link? Yeah, let's take a break. Do we have the community link, guys? Wait, let me share you the community link. Please paste this error and community with the screenshots and the entire error statement, so that we can try to get the solution from there. Yes. So here we go with the community link, guys. Please upload everything in the community. I'll share you the community link. Please save it somewhere. Please save the community link. After restarting Anaconda, it's available. Okay. We'll see. Please copy this error and upload the screenshots in community. We'll check. We'll check. We can go for a break, guys. It's kind of weird. It's working for a few of us. It's not working for a few of us. So please upload the thing entire story in community, so that we can get to a proper solution. Okay, now let's take a break, guys. Let's go for a break. Everyone. So everyone is back now. Perfect. We can continue and we can start new topic, that is text vectorization. Okay, vectorization. Now in vectorization we have two types of vectorization. One is count vectorizer and TF-IDF vectorizer. Okay, count vectorizer and TF-IDF vectorizer. Now let's understand the count vectorizer first. So please help me with some small sentences, for example, like just for a sample. Let's take some small sentences, some feedback, small feedback reviews, sentences, anything. Yeah, guys, just help me with some small review sentences, please. ML is huge, remember all things. ML is huge, remember everything. Our first NLP project. Okay, let's keep these two only. Let's keep these two only. So what will happen? We will try to get the vocabulary, right? We will try to get the vocab, right? Now vocab is all the unique words that are available in the entire document. So like this, there will be n number of reviews. So vocabulary will be all unique words. Let's suppose we have ML, S will be removed in the stop word. Huge is there. Remember will be there. Everything will be there. Okay. Then our first NLP and the project. Okay. So this way we will try to create a vocabulary, and vocabulary is what? The collection of all the unique words available in the entire document, right? So like this, there will be all other words also, and it will simply create a vocabulary that is the collection of all the unique words in a given document, right? Vocabulary clear, everyone? Yes, vocabulary clear, everyone? We simply extracted all the unique words in a given data. right? So in 1 and 2, there will be a lot of such words, right? There will be a lot of such reviews, and out of those, all the reviews, all the unique words will be extracted as a vocabulary. So in that case, it will be first, like the way it's written, that will be the that will be there in vocabulary. Whatever is written, if it is not first or first, like it's written that way, it will be there'll be that word. Okay. No, no, it will simply use, in that case, it will simply take whatever is there. It will simply use this then. Okay. It will simply do this. It will simply use this. Okay. Is why is got dropped because it will be dropped as a stop word, right? Is a stop word and it will be dropped as a stop word. Clear? Then, for the first word, we will simply count the presence of every word in a vocabulary. The first review, ML is present, huge is present, remember is there, everything is there, and these words are not available. Similarly, for the second, these things are not there, these words are available. Right? Now see, the two sentences are converted into vectors now, right? The two sentences are converted into vectors now. So this was a small example when we only have two. In case we have a huge amount of document, we can simply follow the same approach, same strategy to do the count vectorization and convert a specific review, a specific sentence into numbers, into vectors. Clear? Awesome. Now this is a count vectorizer. This is called count vectorizer. Yes, guys, understood? Easy about the count vectorizer? Yes, guys. Now we have another type of vectorizer called TF-IDF. So in order to understand the TF-IDF vectorizer, we need to understand one small concept here. Suppose we are doing the text classification, or we are simply doing the positive reviews and negative reviews. Okay, we are simply trying to classify whether a given sentence, whether a given review is positive or negative. Okay, so during the training phase, we will try to observe what are the words available in positives and what are the words available in negatives, right? Yes, guys. During during the training phase, we'll try to identify what are the words available in positives and what are the words available in negatives. That's what we try to do in during the training phase. Yes. Now, now after this, suppose there is a word good. and the frequency of this word good is very high, means it is also available in positives and negatives both, right? Possible, that could be a possibility. The word good is available in positive and negatives both, right? Yes, good and not good. So if it's written not good, means again it's there in negative comment also, right? So it has very high frequency, it is available in positive and negatives both. But now the presence of this word good in a new in a new review or in a new sentence, we cannot actually try to understand what is the, we won't be get a very meaningful insight about whether a new review is a positive or not, right? It's a positive or negative. The presence of good will not help us much because it's there in both. Make sense? The word good is available in positives and negatives both. So the presence of this word good in a new review will not going to help us in order to identify the sentiment, right? If it is written not good, the movie was not good. So is this word positive or negative? The movie was not good. Is it positive or negative? But the good word is present, right? Okay, so we understood this logic that if the frequency of word is too high, good is going to be there in positives and negatives both, right? And if there is any word that has very high frequency, so that word is not very much helpful in order to identify the sentiment, right? Right? Yes, make sense, guys? This way, if there is some word that is very frequent, the frequency of the word is very high, in that case, that word is not very helpful in order to identify the sentiment. Make sense? Right? So in case of TF-IDF vectorizer, the another vectorizer, that is TF-IDF, that stands for term frequency inverse document frequency. Term frequency inverse document frequency. Okay. Term frequency inverse document frequency, TF-IDF. What this TF-IDF vectorizer will do, it will give less importance to the words that are very highly frequent, the words that are very much frequent, high frequency. It will give less importance to those words, and the words that are less frequent, it will give more importance to those words. Why so? The words that are less frequent are going to be more helpful for the classification. No? Yes? Sure. In TF-IDF vectorizer, if there is some word that is having a huge frequency, so that word is going to get less importance because it's not going to be very much helpful in order to get the right classification. While we saw the example of good, If it is present too much, if it is repeating too much in the entire document, means it is there in positives and negatives both. So the presence of such words cannot help us to identify the sentiment, right? Make sense? Yes, guys? Yeah. So the words with a high frequency will be given less importance, less weights, and the words with the less frequency will be given more weights. Okay? The words with more frequency, the word with the high frequency will be given more weights. Sorry, high frequency will be given less weights, and less frequency will be given high weights. Right? Clear? Yes, guys, clear? Awesome. So that is the another way of transformation from text to vectors, that is called TF-IDF, term frequency inverse document frequency. And we also understood the significances when we should use TF-IDF and when we should use count vectorizer. Yes, guys? That is also clear? When we should use TF-IDF and when we should use count vectorizer, this is also clear? No, not for categorizing the sentence, for vectorizing the sentence. Okay? Sure. In count vectorizer, it will simply place the count of a specific word in a given sentence, and the number of, the length of this vector will be the length of vocabulary, right? Yes, guys, the length of this vector or the length of this array is going to be the length of vocabulary, right? So in case of count vectorizer, we simply place the count of every word, but in case of TF-IDF vectorizer, we use, like we place a number that will carry the importance also. If this remember is occurring too many times, then it will be having less importance. And if there is a word like huge is occurring very less number of times, then it will be having a bigger number here, right? That's the difference. Correct? Correct, everyone? But in both the cases, it is used to vectorize the sentences. Then what is the difference in real life implementation? Okay. So overall approach is to get the vectorized sentence because the algorithms can only work on the numeric data. They cannot work on a text data. So we can only work on the numbers. So that's why we need to vectorize the text data. Is it clear? Great. Now, if we use count vectorizer in case of classification, we discussed about an example if the presence of word good is there in positives and negatives, both the comments. if the good is available in positives and and the negatives both possible. In that case, in a new sentence, if the word good is present, we can't be very confident whether this new sentence is positive or negative. Make sense? So in that case, the good was having high frequency, means it was, it is not very much significant in order to do the classification. So that word will be given less importance. Got the difference? When we should use TF-IDF and when we should use count vectorizer? Perfect. Perfect. Now let's implement a case study. Let's implement a case study for text classification. So in the same folder, you will see a ham and spam filtration. In the same folder, you will see a ham and spam notebook file and also a CSV file, ham and spam CSV. Just open this file and also the CSV. Yes, it's done. Let's start. Sure. So now first of all, simple read CSV, and this is how the data looks like. We have the type, what type of message it is, ham and spam, and what was the message. Okay, so do we know what is ham and what is spam, guys? We know about ham and spam. Exactly. So what's not spam is ham. What's not spam is ham. Clear? Yes. So now let's see the data sheet. We have 5,559 records and 2 columns. Okay. We have 5,559 records and 2 columns, one for type and another one for text. So now let's group it with text and do the describe function. This will give some descriptive data. So what it's telling, the count, unique, top and frequency. So in ham we have 4,812 messages, out of which 4,500 are unique. Rest 300 are getting repeated. 4,500 messages are unique. What is the top message means most frequent? What is the message that is occurring maximum number of times? Sorry, I'll call later is the most occurring ham message, and the frequency of this most occurring ham message is 30. So this is occurring 30 times. Similarly, we have some information about the spams also. We have 747 messages for spam, out of which only 653 are unique. Only 653 are unique. And this, please call our customer service representative, so and so, whatever it is. This one is the most occurring spam message. Frequency of this message is 4 in the entire data set. Clear? Top messages are the ones that are occurring maximum. Clear? Yeah, they are not unique. Awesome. Thank you so much for the efforts. Thank you so much for the command, Aditya. It was so needed. Guys, please save this thing. If anyone is struggling, still struggling with the Ghost script, once this is sorted, if this is sorted, everything will be sorted. Perfect. Thanks, Nami. Thank you so much, guys. Perfect. So, yes, describe function is clear. Describe function is clear, everyone. Great. Now let's calculate a new column. Let's get the length of the data. Let's calculate the length. Now here we have the length of every text. Okay. Here we go. Here we have the length of every text. Clear? Easy? This was easy, guys. We simply created a new, a new column with the name length, and we simply applied this length function to the text column, and it will simply give us the length of the data, length of a message. Okay? Easy? Awesome. Okay, now let's see whether the length is helpful in order to classify the messages or not. So we are simply plotting a histogram here. Now observe the histogram and see if the length is a significant factor in order to classify whether a given message is ham or spam. Yes, guys, please. Yes. Okay. So not. Uh, what about others, guys? Is it significant? What about others? Is it significant, guys? Exactly. So we can simply say it's not significant at all. The length is not significant, right? Clear? The length is not significant for the classification. Clear, everyone? No, we actually don't need the outliers things and other things in this case. Very good. We actually don't need to detect the outliers because it's not the target variable or something. We are simply trying to identify whether the length is helpful to for the classification or not. And here we can see the length is same 0 to 200 only for most of the messages. That's it. So the overall conclusion of this is that length is not helpful for the classification, right? Now, we are simply creating a clean text function that will remove the stop words and the punctuation symbols from the given text. So that's how the clean text function works. We simply created a function clean text that will take a text and remove the stop words and the punctuation symbols from the given text. So see, in this clean text function, we give this document, this text, and this is what it is returning, the clean text. Easy, what clean text is doing? Yes, guys? What clean text is doing? Easy, everyone? No problem. Here, we are trying to remove the punctuations. This will simply remove the punctuation and this will simply remove the stop words. And at the end, if we give this kind of data, this kind of text, it will simply remove the stop words and punctuations and give us only the meaningful and the important words. Right? Yes? Make sense, everyone? We simply calculated the length to see whether the length is helpful for the classification or not. Okay? And after we calculated the length, we observed whether it was significant or not. And by observing the histogram, we can see it's not significant. Got it? What was length and why we created it? Clear? Why we are saying it's not helpful? Because see, the hams and the spams have the same length, 0 to 200 only, right? So this y-axis is the frequency. This histogram is only telling us that we have more ham messages, and that is something we already know. The length of the messages for ham and spam are almost similar. If there will be a significant difference in the length of the messages for the hams and spams, then we can say it's useful, right? Makes sense? If the length is significantly different for the hams and spams, then only we can use length to identify whether it's a ham or spam. Otherwise, we can't. Perfect. Now, we simply created a function to clean the text, right? So no punctuation equals to join no punctuation. That is the join function what we are using. That is the join function what we are using, and this function combines all the elements of our list with a given separator. Perfect. And similarly, we have first removed the stop words, remove the punctuation, then we simply remove the stop words, and then we are returning a text like this. Clear, everyone? Is it clear? Okay. So now we will simply clean the text. We are creating a new column, train text, in which we are storing the cleaned text. Let me show you the train text. Here it is, the train text. Okay. Clear, guys? Everyone? Clear till here? We have the plain text here. Now, the next step is to vectorize the data. Now, again, how do we vectorize? We will simply import the libraries, count vectorizer and TF-IDF vectorizer. So, whatsoever vectorizer is necessary, we can simply use that. We are importing both of them. Right now, we will be utilizing the count vectorizer. So, created created an object for the count vectorizer class, and simply given the train data for fit function. Now, what this fit function will do, it will try to extract the vocabulary. And this is how the vocabulary looks like. We have hope, good, big, checking, kgif, back, thanks, and all these things. These are, this is our vocabulary. These are the unique words present in our entire document, right? Entire 5,000 reviews. These are the words what we have in our entire 5,000 reviews. Clear, everyone? Great. Now we will simply check the length. So we have 9,385. Now tell me, when we will transform the data using the vectorization approach we discussed, what will be the length, what will be the shape of result, guys? That is, this is the length of vocabulary. We have 5,559 messages. What will be the shape of transformed vector? 5559 messages, right? And vocab is 9385 of length, right? So what will be the shape of resulting vector? Anyone? This will be vectorized this way. Okay, let's see. Let's transform and let's see. So 5,559 messages, and every message is transformed to the length of vocabulary. Every message will be transformed to a vector with that is having the length of a vocabulary. Exactly, vocab will be the columns. Here also we use the vocab as columns only. The vocab was the columns, right? And the rows were the number of messages we have. So that will be the length of the data right now. This is our data set, right? Clear, everyone? Perfect. So we created multinomial naive Bayes. Now, in most of the text classification algorithm, we use the naive Bayes, guys. and we simply train and check the accuracy, we are getting a good accuracy, guys. Test accuracy is 98%. That is something good. And we can simply use mn.predict. It will predict for a given data. Test X. So what all messages are there in test X? It is giving the predictions. We can also calculate the confusion metric and the classification report. So we can see everything, every number looks good, 96, 98, 99, 95, everything looks good. So we can accept this model, right? Right? Everything looks good. We can easily accept this model. In naive Bayes, we have to check for all nominals means. I'm sorry, I didn't get you. Okay, but binomial and multinomial, not that is Bernoulli. That is basically Bernoulli and Gaussian. Are you talking about that? Yeah, no. Whenever it comes to the text classification, we use multinomial naive Bayes. Whenever it is a text classification, we use multinomial naive Bayes. Okay. Great. So we also discussed about this pickle exporting and importing the files. Yes, guys, remember? So we can also export this pickle object and we can again read it back as a saved object, right? Now we have simply written a function. Okay, here we will get to know the right approach of train test split as well. See, here we have simply written a function ham spam. It is taking a ROM message, right? Remember, in this training, we had cleaned the text, then transformed, and then we have trained, right? The pipeline is like, first we cleaned, then we did count vectorizer, right? And then we did fit. Yes? So we will do the same thing. Clean, count vectorizer, and then predict, right? So we are taking a text, we are cleaning, passing it to the transform function of bag of words. So it will simply transform this given new text into count vectorizer. Yes, guys? Make sense? We are cleaning the given text and passing it to transform function of bag of words. So it will simply transform this new sentence, the new message to count vectorizer. That is our object, and we are giving this object in prediction, right? We are giving this object in prediction. So we simply have created a function to get the predictions on a new data. Okay, now here we are simply selecting a random message, any random message from the entire database. We are simply selecting a random message. Okay. This is basically just to select a random message. Make sense? So we are selecting a random message and we are passing this random message to ham spam function. It is telling us whether it's a ham or spam along with the probability of being like what is the probability that this message is a ham or this message is a spam. Make sense? Easy? Now see, it's saying it's a spam. Congratulations, you are awarded 500 of CD vouchers of whatever it is. So it's saying it's a spam. Understood, guys? Interesting, the text classification. Easy and interesting, the text classification. Yes. Perfect, guys. So that was the text classification. Tomorrow there'll be only one thing what we will discuss, that is a chatbot, and then we are free to discuss anything else. So the agenda for tomorrow, the chatbot, and let's talk about the deployments. And also, if required, we can discuss about the deep learning and reinforcement learning also. So the first half will be for the chatbot, and then we can talk about deployment, deep learning, reinforcement learning, basics, whatever we will say. How to upload a recommendation in system in website. We will create an engine and we need to interact. We need to integrate that specific Python engine using API or something to a front end, right? So that will require an entire integration with the front end programming and the back end engines. Use API or server programming or anything. Yeah, HTML, CSS, Java is just the web page development. It's only the web page. But whenever we try to interact with the front end and the back end, HTTP request and HTTP responses are something we need to take care of. And the front end dynamic things are built with lots of different frameworks are available, like PHP has Laravel, .NET, ASP.NET is there, Flask is there, Django is there, Java has its own frameworks, right? So it completely depends. There are lots of bunch of tools to develop the front and the back. HTML, CSS, Java is JavaScript, that is just for the web page development. Yes, we need to create a model and we will see how to deploy it. We will also talk about the deployment because we might need to work on the deployment as well. So we should know the deployment thing. And during the deployment itself, we are good if we are able to create an API that can interact with a given HTTP request and response. So I'll see two APIs, but again to understand the API flow, we need to know how web frameworks work. We need to know how web frameworks work. So tomorrow we'll see two APIs. We'll see how we can develop an API. But in order to understand the entire flow, we need to understand how web applications work. Okay? Yes, it completely depends where we want to. But for default or the most better way is to use Docker or something. So we can deploy it on Docker. We can deploy using Docker. So Docker can be placed in any of the environment. Okay. Docker can be placed in any of the environment. What is the average package offered as a fresher? 12 lakhs minimum. Please tell me where is offering 12 lakhs. I want to apply. Now, for a fresher, for a new beginner, somewhere in 4 to 8 lakhs. Somewhere between 4 to 8 lakhs is there for a fresher. But again, it can be more than 8 also, and it can be less than 4 also. Completely depends on the skills and the exposure. But ideally, it's somewhere between 4 to 8. I am working with like I'm part-time trainer. I have a small startup also, and I also have some development contracts. Sir, according to you, which field is more demanded, data science, ML, or AI? We can't categorize it like this. Everything is mixed, right? If we talk about data science, ML, or AI, if you are on a AI field, data science and ML is obviously included. Yes, actually, we used to get the requirements. Definitely, we used to get the requirements, and I hire interns, and based on the performance and other things, we give full-time employment. My LinkedIn, like not regular hiring we do, but again, I have some other connections as well. So we used to get requirements. We used to get requirements. That's my LinkedIn, guys. In LinkedIn, every job requirement is only for the minimum job experience. No, there'll be a entry level jobs also if you will apply a right filter and everything. There are entry level jobs as well, or you can opt for an internship as well. Try to search for the internships also. For the freshers, internships are the best entry points. For the interns, for the freshers, the internships are the best entry point. Okay, yes, guys. Is there anything else, please? Is there anything else, please? If you missed last three classes, you might need to go through with the recorded videos. If you missed last three classes, you might need to go through with the recorded sessions. Yeah. We have covered the unsupervised machine learning, means K-means clustering, hierarchical clustering, time series forecasting using ARIMA, and a priori and association. That's what we have covered. About the recommendation project, that project's data set is full of null values. Can you please check it? Yes, yes, definitely. Help me with the data set and the problem statement. What is the data structure and the architecture? Big data is actually a data management tool. Big data is actually something different than data science. It's more of how do we manage a huge amount of data in a decentralized manner. Means not everything is stored at a single server. Rather, it is being stored in a different nodes. That's what big data is. Okay. Yes, guys. Is there anything else, please? Okay, I got it. 4,848 customers and 207 movies. If there is a lot of missing, consider it that the user have not seen that movie or user have not rated that movie. So just replace the nans with zero. Perfect. Yes, guys. Anyone? Anything else, please? LinkedIn is helpful. I won't say it's necessary, but it's a good plus. It's very helpful for the job hunt, also for networking, corporate networking, B2B marketing, and there are lots of productive things what we can do with the LinkedIn. Like if you ask me personally, the projects or the firm or the projects or the jobs or whatever we do, the LinkedIn is the most productive tool for us. If you are into B2B, if your prospects are more businesses, then LinkedIn is helpful, I think. But in case of B2C, I think the other social media platforms like Instagram and other, Facebook and those sort of social, YouTube also. So if it is B2C, like if you want to target the customers, raw customers, identical customers, then other social media platforms are more productive. But when it comes to B2B, I feel LinkedIn is the best. Perfect. All good, everyone? Okay, yeah, thanks. Thanks for letting me know. I'll see. Perfect. So yeah, that's all for the day, guys. Let's again catch up tomorrow and conclude this entire batch. Only one topic left, that is the chatbot. We can quickly do the chatbot, and then we'll talk about the deployment and other things. Thank you, guys. Thank you, everyone. Thank you all. Bye bye. Take care. See you.
Thank you, sir, for this wonderful session, and thank you all for your participation. I request everyone to kindly fill the feedback survey form and provide the feedback regarding today's session. Thank you all. Take care.